I'm very excited to share my and my colleagues' work on the TES-D, this approach for critically documenting datasets collected from online platforms. Before we get started with that, I want to briefly take the chance and introduce myself. I'm a PhD student in the Computational Social Science department here at KODAQS. In my service part of my life at KODAQS, I'm involved in the web data service as well as the data quality working group. And I hope that throughout this talk, you will find out why this work that I'm now presenting is sort of exactly at the intersection between these different components. So web data and collecting web data on the one hand, and then thinking critically about issues of data quality on the other hand. So I feel like I'm uniquely positioned, at least in our group, to be talking about this kind of work. That being said, my dissertation has now, even though it started with this work that I'm presenting today, it has somehow shifted away from that over time. And I'm now mostly interested in issues of subjectivity and diversity of perspectives in CSS research, and particularly in how to model them using LLMs and persona descriptions or persona prompts. But I think you will also get to appreciate how many of the things that I have been considering and preparing for this work are still informing the issues of subjectivity and diversity I'm thinking about now. So there's, I think, a very clear connection between these two different aspects. Then you also have my email address on the slide. So if you want to reach out with ideas or questions, feel free to do that at any time. And then I also wanted to use this occasion to give a shout out to the collaborators and co-authors for the TES-D. So the original manuscript or paper that we prepared that was being done together with Indigo Sen, Felix Beck-Soldner, Leonie Steinwinker, Maria Zenz, and Katrin Weller. That being said, I'm sort of the person left working on this, and I was also approached by the team at KODAQS with the idea of turning this into a tool for the KODAQS Toolbox, which I will be talking about in a minute. So I'm also now the one giving the talk and having the pleasure of presenting this to you. Okay, so this has been a bit of background on me, and then I want to just start out by giving a very condensed summary of what this talk will be about, because you might be not familiar with this TES-D idea. So what we set out to do was to develop an approach for documenting data sets collected from online platforms, and we wanted to have this approach as a combination of a critical reflection on the research process, which is inspired by how survey researchers are using the total error framework for reflecting on their research processes, and then combining that with the data documentation practices that are increasingly established in machine learning and natural language processing research. And we did all of this with the overall objective to develop an easy-to-use, hands-on tool that would facilitate the systemic documentation of data sets collected from online platforms, and to thereby promote higher data quality by introducing and guiding through this process of critical reflection on the data collection practices. So that's basically the talk in a nutshell, and I hope that in the next couple of minutes and over the next couple of slides, I will give you some more backgrounds and fill in some gaps that might still be remaining with this very crude understanding. So let's get started with some pieces of motivation. So first of all, the appeals of digital behavioral data for particularly computational social science research. I think most people, especially if working in this area, are familiar with that. They know why it's cool to work with digital behavioral data, but just to give others an idea of it. So starting with a very basic definition, digital behavioral data or digital traces can be defined as data that documents the interactions of users with digital devices or services. So think about people using their smartphones as a digital device, or people interacting on a social media site as people interacting with a digital service. And all of these interactions leave some sorts of traces, which we can then go out and collect and thus turn into digital behavioral data, which we might then end up working with in our research and work. Um, and yeah, some of the promises of DBD are listed here. I think they're also very intuitive. We naturally have very large samples. In some cases, we might even aspire to have n equal to all. So basically observing all the behavior there is. Then digital behavioral data tends to be very fine-grained. So you can have in like the longitudinal, the time dimension, you can be very precise, or you can even zoom out and have very long periods of time that you're observing, and also spatially. So you're not restricted to specific geographical regions, for example, but you can actually zoom out and track and observe behavior all over the world. Then DBD is immediate or can be immediate. So, for example, thinking about data collected via APIs, you would often have the streaming functionality of the API where you literally in real time collect the data that is being posted on the platform itself. And then the last point, cheap to acquire. That definitely was true a couple of years ago when we had all these freely available research APIs, for example, for Twitter, where researchers could just sign up, create their developer's account, and then be able to collect DBD at scale. But I put this still true here at the end because this has changed and is changing in the last couple of years with more and more platforms and sort of data providers closing down the access to their data. And I think there are a couple of reasons for that, including the increased valuation and appreciation for the data that these platforms are collecting, and especially in the context of them being used as training data for large language models. So I think people have just been aware of how valuable the data is, which then again is sort of telling us how interesting the data might be for us to work with in the form of digital behavioral data. Okay, so these are some of the promises of DBD, and then obviously here we at GESIS, and in particular in the computational social science department, we are trying our best to make this data available to other researchers who might be interested in working with that. And I'm just listing some examples of the data outputs that we are having at GESIS. So we have the GESIS Web Data Service, which, as mentioned before, I'm a part of. And we are responsible for collecting data sets from online platforms. And for example, over the last couple of years, we have been tracking the social media activities of candidates running in the federal and European elections. And you can find these data sets in the GESIS archive and on our GESIS Web Data Service website. And then there are also large-scale collections of Twitter or X and Telegram data that can be accessed via the GESIS archive. And we also have, for example, knowledge graphs of fact-checked claims. So these are some examples of digital behavioral data collected at GESIS. And this sort of portfolio is rounded and extended by things like the GESIS web tracking or the GESIS panel DBD, where we have internet activity data of participants. So basically observing and collecting the website visits of people who agree to participate in these kind of studies. And then there's also the GESIS App Kit, which can be used to collect digital behavioral data in the forms of smartphone-based surveys. So the App Kit is providing the infrastructure for that. And then you can do stuff like experience sampling or ecological momentary assessment. So basically, in very controlled and fine-grained time intervals, sending out surveys to the participants. And I think the people in the app kit, they are currently working on extending this towards including sensor data such as GPS location and smartphone usage. So these are some examples of the digital behavioral data we are having here at GESIS, and also to give you an idea of what data we might be talking about in the upcoming slides. With that shameless advertisement for GESIS web data and GESIS data services, let's get back to the TES-D and to the motivation of it. And I wanted to start that with a case study. So one of the very early examples where people have found a promising way of using digital behavioral data was this paper called Predicting Elections with Twitter, What 140 Characters Reveal About Political Sentiment. And that was published in 2010. And the researchers here, they had the idea of tracking the public discourse on Twitter, on a social media platform, and then seeing how often the different parties running in the election would be mentioned on the Twitter platform. And then their idea was that the volume of the volume of the mentions, so the sort of focus of the discussion on Twitter, would be or could be indicative and even predictive of the election results. So they during a period running up to the election, they would collect all these mentions involving the different parties. And then you see here this column saying all mentions and number of tweets. Then they basically took these and turned them into relative shares. And then they compared these relative shares to the actual election results. And what they are finding here is that just looking at the volume of the Twitter traffic on the different parties, actually leads to a very good prediction of the election results. So you have deviations of like single digit and very small percentage points, and resulting in a very low mean absolute error. And the researchers actually compare this prediction or predictive performance to the predictive performances of more established methods, for example, election polls and general opinion polls, and that they find that using Twitter data is actually comparable to these more established methods, which is in itself a very exciting finding because running these large-scale election polls is quite costly. And if you could just go on Twitter, collect data there, and then use this to predict the elections with the same level of accuracy, then that's obviously very exciting. And that also led to this paper being accepted at quite a good conference, the ICWSM, in the computational social science context. But then, I mean, some of you might already either be familiar with the paper or thinking of some obvious flaws of this research design and setup. There came a response to this, and the response had the very nice title of "Why the Pirate Party Won the German Election of 2009" or "The Trouble with Predictions," a response. And the authors here, they first set out to simply replicate the research design of the original study. So again, they were using the Twitter API to collect the mentions of the different parties in the run-up to the elections. So here, the left-hand two columns, these are coming from the original paper, and then the two columns on the right, these are the replication efforts. And while we see that there are some deviations in the absolute number of mentions collected. So the later effort, the replication effort, was able to collect substantially more mentions for the different parties. The relative shares, they were still somewhat comparable. So you could argue, okay, the absolute numbers might have changed, but like the tendency is the same. So maybe the performance as a sort of predictive tool might still be somewhat validated and okay-ish. But then, and then here the like slight criticism that this response would be making is that there are some missing or vague details of data collection in the first study, and these make it very complicated to do a full replication of the paper. So basically I think they didn't give the full details of the cutoff dates for the data collection and also the settings of the API parameters, for example. So these were like minor replication concerning criticisms, but then the whole results substantially change as soon as you do like this very minor change in the design of the whole setup by including a seventh party for the data collection. So we have the same six parties listed before, but now we are also collecting data for the Piratenpartei. And if you do that, everything changes, because then if you look at the share of the Twitter messages here on the right side, so the volume of how many times the parties are being mentioned, you find that the Piratenparty is actually the most discussed Partei on Twitter in the run-up of the election. And then if you want to use the tweet volume as a sort of predictor for the election results, you end up in a very bad place where suddenly you are predicting the Piratenpartei to win the elections. And again, this is just the result from this very, very minor design change, which is completely reasonable to just add in another party for which you are collecting the tweets and then calculating the relative shares. Um, so, I mean, the sort of mechanism behind this is quite clear because the Piratenpartei was quite heavily discussed in the media back in these days, and particularly online on social media, because it was a very online-focused party. And then this obviously biases the volume of tweets that you're collecting and that you're ending up with, and then leading to these changes in the sort of predictions that you're making. And this sort of leads to the much larger criticisms then that there's a missing justification for the crucial design decisions that are leading then to somewhat or very arbitrary results. And if not properly documented, other researchers might have been completely unaware of the impact of these design decisions. So that then obviously complicates the decisions involving whether you want to reuse a method or whether you want to reuse a data set. And that might lead to other people just reusing that without reflecting on whether adding another party might change the results. So sort of a lack of validity and quality of the research design here. And yeah, this is sort of the origin story for our effort to create these total error sheets for dataset, because we wanted to have a data documentation template for this kind of digital behavioral data that focuses on a critical reflection on the data collection process. So ideally, we would want to be able to have questions in our data documentation template that would sort of make these influences of minor design decisions explicit, and thus help researchers to better document it, to better understand it for themselves, and also to share these potential limitations of the data collected with other researchers. Yeah, as I mentioned, that's supposed to be, on the one hand, guide for the critical reflection on the collections of DBD, and then also something that helps to systematically identify, document, and communicate these limitations and flaws. And then some information and background on the development process we took. So we are basing this on two different ingredients. On the one hand, we have the TED-on, which is the total error framework for digital behavioral data. That was developed and presented by other colleagues here at GESIS under the lead of Indira Sen. And they were taking this idea from survey research, where you would have total survey error frameworks that help to critically reflect on the survey research process. And they were transferring and translating that to the work with digital behavioral data. And then as a second ingredient, we have data sheets for datasets, which is a data documentation approach developed by Timnit Gebru and colleagues. And that was proposed for documenting datasets in machine learning and natural language processing. And I'm just briefly giving you some more background on these two ingredients. So the TED-on framework, as mentioned, translates the total survey error from surveys to the DBD research process. And we see like a very abstract version of it here on the right. So we have the research process in the middle, starting from construct definitions. So what are you setting out to measure? For example, in the case study that I was presenting, it would be election shares or election performance of different parties. And then as a second step, we would have the platform selection. So in the case of the case study, we are looking at Twitter. Data collection, there you would find discussions of details of how the data is actually being collected. So maybe via the API, and then you would have some potential errors arising here based on how you're collecting the data and who you're collecting the data on. And then the next stages are data pre-processing and data analysis, but you can sort of model the whole research process following these 5 steps. And then for each of these steps, we would have different types of errors that could potentially arise. So these errors are separated into measurement and representation errors. And the idea here is that it helps to identify the crucial design decisions at every stage of the research process, and then pointing to potential errors of measurement and representation. So the TED-On is sort of delivering this critical reflection part of what we want to have in our TES-D. And then on the other hand, we are looking at data documentation approaches in machine learning research. And just to give a bit of background here, so in the machine learning research and particularly the NLP community, we have had an increased scrutiny of data sets starting a couple of years ago. And that's very closely related to the increasingly important role that data sets and data play in recent advancements of the field. And I think the best and most well-known example is the development of large language models, because the paradigm for the last couple of years there has sort of been not to really focus on methodological improvements, but to rather scale up operations. So you would just add more and more data to the training of these models and then increase the size of these models. And the improvements that we've seen over the last couple of years can, to a very large degree, attributed to just scaling up the training data and scaling up the size of these models. So on the one hand, increased importance of data, and then on the other hand, the realization that the models that are resulting from the training on this data, they actually perpetuate, sort of learn the harmful biases and the behaviors found in the training data. So we have this whole conversation about or around aligning LLMs and having some sort of safeguards and guardrails in them. And those are necessary because of the tendency of models to just perpetuate whatever they find in the training data. So if you have, I don't know, very ugly misogyny and racism that somehow ends up in the training data because the training data is actually a reflection of what happens on the internet, then the thinking is that you will actually find the same types of behavior in the resulting models. And that's sort of the motivation why people started to better document the data sets that are going into these models in order to understand the behaviors and be able to eventually control them. And here are some examples for early research that were focusing on this kind of documentation and critical reflection on data sets being used for machine learning research. Yeah, and then in particular, we were picking the data sheets for data sets approach because it was one of the earliest and most prominent ones proposed for documenting machine learning data sets. And their objectives, as sort of sketched out already, is that they wanted to increase the transparency and accountability of this kind of work. They wanted to help mitigate unwanted societal biases, improve reproducibility, and also increase the reusability of data sets. Because if you're able to understand what's in them, you might be better able to also reuse them for your own research. And then the idea of how you might be able to work with data sheets for data sets. So that's in the end a list of questions that's categorized along the dataset lifecycle. And these questions elicit information that is deemed relevant for the documentation of machine learning data sets without being prescriptive, but adaptable to the context. So you end up with having a list of questions that you are answering based on the dataset that you have compiled. And then the thinking is that you can share the answer to these questions together with the dataset, and then people don't have to do all the processing and analysis of the data set themselves, but they can just look at your answers to the questions in order to understand the contents and composition of the data set. Yeah, so these are the two ingredients that we were taking for our TES-D, and we were trying to somehow bring them together. So on the one hand, the sort of critical reflection on working with digital behavioral data coming from the TED-On, and then on the other hand, this idea of it's necessary to document what's in our data set, and here is a format that might work. So we started out with a question catalog that we found from the datasheets for datasets, and then we try to take the different steps identified in the TED-On as the sort of framework for us and use them as question categories. And then we were sort of mapping the datasheets questions into these categories and also adding new ones where necessary. And then in the end, we added these more DBD-specific questions based on the reflections that we found in the TED-On framework. So that's in a very high-level abstract way, the steps that we were taking in order to bring these two resources together. And then the sort of last step for us was to devise materials for the use, creation, and sharing of TES-D. And we came up with three sort of different but complementary formats. So on the one hand, we have a more visual documentation template, and you see the gist of it here. We again have some abstracted version of the research process, which is very similar to what we have been seeing in the TED-On framework. And then again, we find these different categories of errors. And then the idea would be that you can jump into the set of documentation questions, so very similar to the datasheets for datasets approach. And there you would find like very concrete, very specific questions that you should answer for your dataset. And then you can put these responses and these pieces of information into the documentation template. And in the end, you would have this handout type thing that you could upload together with your dataset in order to document its content and its potential uses. And the thing that is supposed to help you with all of that is the TES-D manual. And there we again have all the questions that we have in the set of documentation questions, but we provide discussion and context on each and every one of these questions. So we would tell you why answering this question for a dataset might be relevant to other researchers. So we are trying to really help people understand why they should answer these questions for their dataset. Last, so after you've seen the different formats and the materials of the TES-D, I want to briefly tell you how we think you should be working with it, if you want to. So first of all, before data collection, we think it might make sense to consult the TES-D manual. So this more expressive handbook that we wrote to reconsider the planned research design. So basically go through the things that we're listing here and see whether you think that some of the questions might trigger some critical reflection on the steps that you're planning in order to collect, process, and analyze the data. Then during the data collection, we think it makes a lot of sense to fill in the TES-D template and the questions in parallel to collecting the data, because then ideally you save some work because you don't have to do it retrospectively after having compiled the data, but you can sort of do it on the fly and create this documentation as you go along. And then after the data collection is finished, and after you have compiled your data set and after you're ready to share it with other researchers, you can just take the prepared TES-D template and the questions that you answered and upload them together with the data set to wherever you are sharing the data set. And then other researchers can just look at that and use it to, to understand the characteristics of the data set itself. And then just to wrap this whole case study idea up, so let's see how the TES-D might have actually helped with this piece of research. So for example, in the TES-D, we have the question, over what time frame was the data collected and how might the time frame have affected the collected data. And in the context of this predicting election results with Twitter data, this question is actually very relevant. So the people who wrote the response to the original work, they actually did this sort of ablation thing where they looked at different periods of time for which they collected the data. And these periods, some of them, they just like changed for individual days or single days that are included or not included. And if doing that, we see that the mean absolute error reported for the predictive performance is actually fluctuating a lot. So um, the criticism in the response here is that the original research, they don't give any account of why they decide to choose this period, and the results thus depend considerably on the period under scrutiny. And by answering this question that the TES-D is sort of proposing, I think this would have been alleviated right from the beginning, because then you would have at least some documentation of the actual collection period and why exactly it was chosen. And another example would be the question posed in the TES-D of how was the data associated with each instance acquired and on what basis were the trace selection criteria chosen. And again, that's directly related to this decision of including or not including the pirate party. And in the response, we see that they say, okay, so they chose to include 6 parties, but they don't make transparent the reasoning behind this choice, however. And by giving no account or rules, obviously this limits the applicability of the proposed instrument. And I think if the researchers behind the original work, if they would have had the TES-D and if they would have answered their question, then they might have increased a bit the transparency and the reasoning for their design choices, and thus maybe would have averted this kind of response they triggered with their research just by making explicit their choices here. Yeah, and then to start wrapping up, some reflections and outlook. So the objectives that we had with the TES-D is to increase the quality of collections of digital behavioral data, and particularly data collected from large online platforms, and also to help lower the burden of data documentation. I think there is increasing awareness that it is important to document data, but oftentimes it's being described as very burdenful, and people don't want to invest the additional efforts. And we hope that TES-D helps lowering these burdens. Then we hope that this improves reproducibility and transparency of research. And finally, sort of shifting perspectives away from the researcher compiling the dataset and towards the researchers interested in reusing the dataset. We hope that this also allows for better informed decisions on whether or not to reuse particular datasets. I think there are some things that are still missing in the context of the TES-D, and one of them would be to evaluate whether TES-D actually helps in achieving these goals. So conducting some sort of user studies and seeing how people engage with it and whether the resulting data sets are themselves better and are better documented. And then this is maybe the most crucial part around it, to try and establish some sort of incentive structures around critical data documentation, because I think that's the thing that stops most people from doing this kind of work. There are no or very few incentives for doing that. You might get away with just publishing the dataset without documenting it at all. And I think having some sort of incentive for actually sitting down and doing a good data documentation would be super helpful in promoting this whole idea. And then to sort of finish off and to maybe leave you with something that you might want to discuss later in the discussion part, or just think about for yourself, is the question whether we should partially rely on LLMs to fill out the TES-D. And I think there are different versions of this idea. So one would be, okay, I as a researcher, I have created the data set, I have wrote the code to collect the data, to process it, to analyze it. and I have maybe wrote a paper on the data set, and then I can sort of put all of this into an LLM and then ask it to fill out the TES-D, for example. So this would be one option. And then do you think that makes sense? Do you think things get lost? Because obviously you're not doing the critical reflection yourself, but you're sort of outsourcing that to the LLM. And that might be something that we don't want to outsource to the LLM because that type of work is important and we might want it to not be as generic as LLMs might sometimes be. And then the other, maybe more extreme variant of this is that we see more and more people not even coding and programming themselves anymore, but relying on these LLM agent-based setups where you would have maybe even a team of LLMs working together, producing the code, analyzing the data for you, and you're just sort of curating and checking at the end whether it makes sense in the best case. In the worst case, you're just relying that the LLMs do a good job by themselves. But here you could envision that if you have a team of agents working on your data, you might even have a data documentation agent whose whole job in this process is to document all the steps that are happening while the data is being collected, processed, and then finally analyzed. And maybe that agent gets access to the TES-D, and then it would be able to sort of on the fly document stuff in this more explicit format. So I think these are two ideas how we could actually, for example, lower the burdens and make it more make it easier for people to create this type of data documentation, but maybe, or I'm sure they also have their disadvantages. And I'd be happy to get your thoughts on that in a minute when we start the discussion. But before we get there, I just wanted to very briefly show you where you find the TES-D. So the TES-D is part of the KODAQS Toolbox. That's why we had the talk today. And then there's also a preprint available on Archive, and you can find it here by clicking on the link. And I just want to very quickly show you where to find the TES-D in the KODAQS Toolbox. So that's the landing page of the toolbox. And then if you go into the digital behavior data type, you see the TES-D listed as one of the tools here. And you can just click on it, and there you find some context around it. So some of the parts that I was presenting here today. And then you get to the actual documents that I've been showing you. And you can sort of look at them for yourself. And then we also have this nice little application and use case giving you an example of how it might look like if you fill out the TES-D. Yeah, and you can just jump into the KODAQS Toolbox and explore it for yourself a bit. And if you're there, also check out all the other amazing tools. I'm sure there's stuff that's interesting for you and your research. And yeah, that's my part. Thanks a lot for listening and looking forward to any questions and discussion points.